Let's look at some basic rules of integration. So the first one would be if you have the integral of any constant k with respect to x. The result of this is just going to be the constant times x plus c. Remember, you put the plus c here because it is indefinite. Once we get into definite integrals, you will no longer have this plus c. So an example of this would be perhaps the indefinite integral of 5 with respect to x. That's just going to give us the result of 5 times x, 5x, plus c. The next basic rule of integration, and probably the most important one, is this one. If you are looking at the integral of x to the nth power, where n does not equal -1, with respect to x, you're going to always do this. You're going to first add 1 to the exponent, and then you're going to divide by the new exponent. And you're going to add c to that. So an example of this might be the indefinite integral of x cubed with respect to x. So all we're going to do is look at the exponent 3, and we're going to first add 1 to it, then we're going to divide by that new exponent, and then add c. And then of course we simplify if possible, giving us this final result, x to the 4th all over 4 plus c. This example deals with 2 or more things going on within the same integral. Here's how we're going to handle it. We're going to do one thing at a time. We're going to do it term by term. So this symbol, the integral symbol, is telling us to do something with each of these 3 terms. Here is exactly what it's telling us to do. First term, when we look at the indefinite integral of x to the 5th, we will do what? Add 1 to the 5, do that first. 1 plus 5 is 6. Then you divide by the new exponent 6. Moving on to the second term. Here we're looking at what is called the constant multiple rule. So the 4 stays in front. It's not going to change. What will be changing is this variable component x squared. That's going to be x to the 2 plus 1, which is 3. And then you divide by that new exponent 3. Finally, minus 7. That's a constant. So the integral of a constant is just going to be the constant times x, so -7x. Again, because these are indefinite, make sure you always put the plus c at the end, and we're finished with that example. There are 2 special types of integrals. The first type is the integral of e to the x with respect to x. If you recall, when we were looking at derivatives, the derivative of e to the x was e to the x. Well, guess what? Now the integral of e to the x is also e to the x. And again, because they're indefinite, make sure you put the plus c at the end. The second special type is the integral of 1 over x with respect to x. Note that this does mean exactly the same as this, the integral of x to the -1 with respect to x. Well, you can't apply the rule we looked at earlier because there is a -1 here. Think about it. If you were to add 1 to this, you get x to the 0, and then if you were to divide by 0, you'd get an undefined situation. That's not correct. What is correct is this. The integral of 1 over x, or same as x to the -1 with respect to x, is always going to result in the natural logarithm of the absolute value of x, and then because they're indefinite, you put the plus c at the end. Note, if you recall when we discussed derivatives, the derivative of the natural logarithm of x was equal to 1 over x. What we're doing here is basically the opposite of differentiation when we look at integration. Hope that helps. Have a good day. Hang in there.